Hello everybody and welcome to MTN Teleschool. My name is Samanenga. I'm pleased to be on this MTN platform to help you prepare for your final exams, and I'm a specialist in mathematics subject, and today we'll look at some questions from 2017 General Certificate of Education paper 2. Please remember to tag your friends and families so that they can also join us in this live streaming. We've received overwhelming comments from the people that are viewing us, Mtalechi Mfwembe also, and many others that are viewing us. Please continue sending those comments. Those that feel they cannot afford to follow us, the live streaming will be uploaded on MTN TV Plus after an hour of the live streaming. So you don't need to worry much, because we've also received some comments to say why can't it be done in the evening when everyone has knocked off. Right, so we go straight to our first question this afternoon. The first question is on matrices, and we have been given to find the determinant of a given matrix and also to find the inverse of a given matrix. And thereafter we are going to look at a quadratic equation and how best we can solve it, and that gives us some 5 marks also on it. Suffice also to mention that when we're dealing with quadratic equations, the number of marks determines what formula you are going to use, and so you don't need to stress much because we are going to look into that. So going straight to our question, the question reads, given that matrix K equals 10, negative 2, 11, negative 2, then the question here states find the determinant of K. Find the determinant of K. So we have been asked to find the determinant of K. So in this case, we need to know how the determinant under matrices is denoted. So determinant of K is simply the product of the major diagonal minus the product of the minor diagonal. Someone may be wondering now to say which one is the major diagonal and which one is the minor diagonal. So when we get back to the matrix given, this is our major diagonal and this is our minor diagonal. And so what are we saying? What we are saying now is the product is 10 times negative 2 multiplied minus 11 times negative 2. Right. So if we multiply 10 times negative 2, we have negative 20 minus, in the brackets, 11 times negative 2, we have negative 22. And so if we expand the brackets, we have negative times negative, we have negative 20 plus 22. And if we simplify that, negative 20 plus 22, that gives us 2 as our determinant. Now, we need to look at the inverse of the given function, the inverse of the given matrix, and the matrix given is K equals 10, negative 2, 11, negative 2 as well. So we are going to use now the determinant that we have already found in the quest to find the inverse of matrix K. So K inverse, as it is denoted, is given by 1 over 2, then multiplied by the determinant of K. But first of all, we have to interchange the elements in the major diagonal. So we're going to have negative 2 goes there, and 10 comes down. Then also interchange the signs here. This one becomes negative 11, and this one becomes 2. And then from there, we can go on and say 1 over 2, when we expand this, is going to give us 1 over 2 by this gives us K equals negative 1, and this by this we have 1, and then we have negative 11 over 2, and we also have 5 here. So this is the inverse of the given function. This is a negative 11 and 2. Okay, I'm sure you're able to follow that one. Right, so we move on now to our next question. This one has already been done. We also did it in the first part of the session that we had this morning on matrices, and we did quite a number of questions on matrices. Now we are going to look at the second question, which is question part B. Question part B states to solve the equation 3z squared. The students are used to x, so it's 3z squared equals 7z minus 1. Then they're saying giving your answers correct to 2 decimal places. Earlier on this morning, I alluded to the fact that a quadratic equation is simply an equation of the second degree. And when we are talking of this equation of the second degree, we are looking at the highest power to which the variable has been raised to is 2. And there are many ways in which we can solve a quadratic equation. This morning, I earlier on said we can solve the quadratic equation by factorization. That is, if the equation given is factorable. But if the equation given is not factorable, then it means that we are supposed to look at alternative methods which can help us solve this question. And these alternative methods include using the quadratic formula and the complete of square method, and so on and so forth. So this question in an exam carries 5 marks, and whenever you're seeing the 5 marks, it means you can either use complete of square method or use the quadratic formula. But first, before we use the quadratic formula, we need to rearrange this equation properly. So we are saying 3z squared, collect the terms, this 7z minus 7z, and then plus 1, and gives us what? 0. We have transposed this to the other side, and then we have remained with 0. Great, I hope you're able to follow. Then from this same equation that we have, we need to ascertain what is our A, our B, and our C, because the quadratic equation, this equation, we're going to solve it using the formula which states that x equals negative b plus or minus the square root of b squared minus 4ac, and everything should be over 2a. Be careful with the division line. We are starting from here going up to somewhere there. Most of the times as students we make mistakes because the division line will always start from where the square root sign starts. Okay, now that we have written down the formula for this equation, x equals negative b plus or minus the square root of b squared minus 4ac, everything over 2a. Now we need to find the value of a B, and C in the given equation. But you realize that in the given equation, we do not have, in the given equation, the coefficient of, we do not have, the variables in this equation are Z and not X. So our formula will slightly be written as Z, because we are calculating for Z, instead of X, equals negative B plus or minus square root of B squared minus 4AC, everything over 2A. Right. So now we need to find the value of A, the value of B, and the value of C from the given equation above here. So the value of A is equal to the coefficient of Z squared. The coefficient is simply a number that is in front of the variable or the letter. So Z squared, the coefficient is 3. So we are going to have our A to be 3. And our B is the coefficient of Z. This whole, we lift it with a sign, which is negative 7. And then our constant, our C, is going to be 1. Having found or identified these numbers, then we replace them in the given formula. Right. So we have Z equals negative B plus or minus square root of B squared minus 4S. Take note that the value of B is negative 7. Do not confuse yourself with this negative which is there. Let this value of B be lifted the way it is, and we're going to insert it here at negative 7 like that, plus or minus the square root of negative 7 itself, which is the B squared, minus 4, then the value of A is 3, and the value of C is 1. Everything should be over 2, and the value of A is 3. Right. I'm sure you are following nicely there. And so what we are going to do now is simply to simplify the given equations. This negative is expanding that, so we are going to have 7 plus the square root of negative 7 squared gives you 49 here. Then 4 times 3 times 1, we have minus 12. Everything plus or minus here, I beg your pardon. Then everything over 6, because 2 times 3 gives us the 6. Now from there, we are going to progress slowly and say 7 plus or minus 49 minus 12. We have 9 minus 2, that is 7, and 4 minus 1, that is 37. So you have the square root of 37, everything over 6. We are calculating for the value of Z. And earlier on, I said that a quadratic equation is an equation of the second degree, meaning the highest power to which the variable is raised to is 2. And this 2 is signifying the number of solutions that you are going to attain at the end of the day when you solve this equation. So we are going to say either 7, we take the positive 1 plus square root of 37, I'm going to split them this way, over 6, or Z equals 7, we get now the negative part, minus square root of 37, everything over what? Over 6. So having done that now, we need to find the square root of 7. By the way, you need to be mindful that this paper is a calculator version paper, so calculators are allowed to be used. And so if you say 7 plus the square root 7 plus the square root 7 plus the square root 7 plus square root, beg your pardon, square root of 37. I'm trying to make some calculations here. 7 plus square root of 37. You have the whole answers 13.08 276253. It's important that you do not round off any figure at this level, because if you round off anything at this level, you are going to have some problems in terms of your answer. So we also divide it by 6, and so when we divide that by 6, we are going to have, which is 2.180460422. This is one value of z. We are still calculating for z. Then the other value can say, or now we are subtracting to say 7 minus the square root of 37, and this gives us 0.917237,469. Okay, sorry about that. Then this is going to be divided by 6 also. So now we say divided by 6, we are going to have 0.152872911. Now when we get back to the question states, solve the equation 3z squared equals 7z minus 1, giving your answer correct to 2 decimal places. And this is the reason why we did not round off these numbers in the initial stage. So what we are going to do now is we are going to round this off to 2 decimal places. So we have 2.18. When we look at this, is this 0 above 5 or equal to 5? It cannot round off this one. So this will be one value of z, or the other value of z will be 0.15, and then the 2 here cannot round off or cannot change that. So these are the solutions for our quadratic equation. So you can either solve it by using the formula, or you can either the quadratic formula, or you can either solve it by complete of square method. But in most cases, when you look at the revised curriculum, even the quadratic formula has been put for you there so that it can easily help you to work out one or two things without a lot of difficulties. So that is what you needed to know about solving quadratic equations, and you don't need to stress. It's 5 marks, so you need to do a good job in order for you to score a lot of marks in your final exams. We are grateful for the comments that are running. Well, Chimfwembe is following the presentation. Mutale Chimfwembe is following the presentation. Please continue dropping those comments for us. We appreciate. And the others also. Susan is also saying hello, and they are happy that they are following this presentation. We now move on to the next question. Our next question is simply, we've been asked to simplify m squared minus 1 everything over m squared minus m. I think if you're able to remember, earlier this morning we looked at the factorization of difference of two squares. When we look at this given fraction, m squared minus 1, everything over m squared minus m. Let us look at the numerator here. The numerator and the denominator here. When you look at the numerator is m squared minus 1. 1 can also be squared. When we square 1, it's the same as 1. So this is already a difference of two squares. So we are going to factorize it using the difference of two squares. So we have on the numerator m squared minus 1. When factorized using difference of two square method, we are going to open up two brackets like this. We have m here, then the other one m, and since 1 is squared, which is just written as 1, we can write another one here, either plus here or minus here. The order does not really matter, like we said this earlier, to say, even if I write it to say m minus 1 and m plus 1, it is the same because these factors are being multiplied. We are multiplying these factors. And when we multiply this and this, we'll still get back to the original expression that we had as the numerator. So for now, we have it that m squared minus 1, when factorized using difference of two squares, we obtain m plus 1, then m minus 1. Now we need to factorize the denominator of this fraction. The denominator of this fraction is m squared minus m. So factorizing it, we have m, then m minus 1. If we expand the two, this and this, we are going to end up getting this denominator. So now that we have factorized both the numerator and also the denominator, we are going, and we can see that the numerator has factors that are multiplying. It's not a big mistake to say this factor and this factor can eliminate. And so we are going to have m plus 1 over m as our required simplification of that expression that we've been given. So there is factorization that is involved in that simplification, and you need to factorize the numerator separately and the denominator separately. Then from there you move on and see how best you can simplify the given expression. So we move on to another question. And this question is question 2b, and is based on arithmetic progression and geometric progression. Earlier on this morning, I alluded to the fact that in our revised curriculum, we have the APs and GPs, which I'm calling the APs and the GPs, arithmetic progression and the geometric progression, have been included. In the past, when you go through question papers 2015 and going downwards, you will not find the APs and the GPs included in the final paper. But this time around, you need to bear in mind that it has been included, and that's the reason why we want to look at one or two questions. So the question states, the first three terms of a geometric progression are 6 plus n and 10 plus n and 15 plus n. So this is the first term, this is the second term, and we can call this as our third term. And then they continue to say, find the value of n. Find the value of n. How do we find the value of n? To find the value of n, we'll first need to find the common ratio. We are going to do it in such a way as if we are finding the common ratio. How do we find the common ratio? The second term divided by the first term equals to the third term divided by the second term. So what am I saying? What I'm saying here is that 10 plus n divided by the first term, which is 6 plus n, will be the same as 15 plus n divided by the second term, which is 10 plus n. So, but in this case, we've been asked to find the value of n. So we are going to cross multiply this so that we have 10 plus n multiplied by 10 plus n, if you are able to follow, equals 6 plus n multiplied by 15 plus n. Right. So now we can expand the brackets. When we expand the brackets, we have 10 times 10. This gives us 100. And 10 times n, this gives us 10n. N times 10 also gives us 10n. And n times n gives us n squared, which is equal to, we now expand the right hand side of the given expression, 6 times 15, this is going to give us 90, plus 6 times n. This is going to give us 6n, and then 6 times 15, 90, 6 times n, 6n, then n times 15, we have plus 15n, then n times n is going to give us n squared. Right. Now, we are going to collect the like terms because we have expanded the brackets. Now we want to collect the like terms. You can see that if this positive n squared is collected to this side or is transposed to this side, it is going to eliminate this one. So this one and this one is eliminated. So we are going to have 100 plus, when we simplify this, we have 20n, and when we simplify this also, we have 21n, and if this 21n is transposed to the other side, we are going to have minus 21n. Then we also say we have now equals 90 this side. So if we want, we can also transpose this 100 to the other side so that we collect the like terms. So we have 20n minus 21n equals 90 minus 100, because 100 is positive this side, so when we collect it to the other side or we transpose it, becomes negative. And 20n minus 21n, we are going to have negative n equals 90 minus 100, we are going to have negative 10. So dividing or multiplying through by negative 1, we have n equals 10. So the value of n they were asking us to look for is 10. Right, so now we move on to find the common ratio. Now that we know the value of n, we need to find the value of the common ratio. Like I said earlier, we have 3 terms, that is 6 plus n, and 10 plus n, and 15 plus what? N. So the value of n is 10. So in order for us to find the common ratio, we simply say the second term divided by the first term. So we are going to say 10 plus n over 6 plus n. But what is the value of n, like we have already found? The value of n is 10. So we are going to substitute or replace. We say 10 plus 10, that gives us 20 over 6 plus 10. So we are going to have now 20 over 16 there as our common ratio. But then we cannot leave it like that. We can further reduce it to its simplest form. So we are going to say which number goes into 20 and 16 without giving us a remainder. And we have 5 into 20. We can say 4 into 20. We have it comes 5 times. And 4 into 16, we have it comes 4 times. So this is our common ratio that we have been given, which we have calculated for. Now, the next question is asking us to find the sum of the first 6 terms of this sequence. The sum of the first 6 terms of this sequence. So the sum of the sequence is given by the formula S equals A, then 1 minus R n, everything over 1 minus R. You can find that formula even in the table of formulas that has been given in the question paper. So from there, we go now back to our sequence, okay? Our geometric progression, the first term is 6 plus n, but we've already ascertained the value of n to be 10. So we'll say 6 plus n plus 10, this is simply 16. So our first term is 16, which is a. So we're going to say 16, then 1 minus our common ratio is 5 over, that is 5 over 4. Then they have mentioned us to look for the what? Given the sum of the first 6 terms of this what? Of this sequence. So the sum of the first 6 terms of this sequence Now we are going to, we know that it's going to be now the over 1 minus the common ratio, which is 5 over 4. So from there, we just need to use a calculator, expand this so that we are now able to work it out and then find our own answer. As I said earlier on, that's a calculator version paper, and from there it's not really a big problem. You simplify 1 minus 5 over 4, then you also simplify 1 minus 5 over 4 raised to that power, and then you expand, then you find your own answer. Right, mind you, it's a calculator version paper, so you can be able to do that on your own. Okay, so now we move on again with our revision of the questions. I hope you are following well and you do not have any problem. Please drop us a comment as you are following this live streaming of MTN Teleschool. As we go to the next question, I just want to clear this space so that we do not have problems on where to work on. So our next question is coming just after the break. For now, we're going to break for 2 minutes and we'll be back. Please stay tuned and don't go away. Thank you.
Rise up this morning, smile with the rising sun. 3 little birds pitch by my doorstep, singing sweet songs, our melodies pure and true, saying, this is my message to you. Singing, don't worry about a thing, 'cause every little thing is gonna be alright. Singing, don't worry about a thing, 'cause every little thing is gonna be alright. Cause every little thing is gonna be alright.
How you use your data is up to you. With the widest network coverage, it's amazing what you can do on MTN.
This is my message to you.
It's free! It's all free!
Imwe, twanya again and again. MTN brings you an even bigger, bolder, more delicious offer. Matemeto DVD. Stream, download, browse, and upload without using your data for 1 whole month. Get free Instagram, MTN TV Plus, free MTN Music Plus, Facebook Flex, and free WhatsApp when you get Matemeto DVD. It's incredible. All you have to do is recharge with 2 kwacha and get it all for free without using your data. Offer is valid up to midnight of the same day. Terms and conditions apply.
Everywhere you go, MTN.
MTN Teleschool. Again, my name is Anton Samanenga. I'm taking you through the Mathematics Paper 2 2017 General Certificate of Education. I would like to thank Raphael, Chembe, Brian, Bex, Vusi, Pilila, Sheyenge, and all those that have tuned in to MTN Teleschool. Please, we value your support and we are happy that you are following us. Maureen also is saying hello there. We are able to see here that you are able to follow our discussion. Austin Piri also, thank you so much for tuning in, and many others that are still dropping their comment to encourage us to move on with the MTN Teleschool. Right, at this moment in time, we are going to look at another question, and this question is on sets. The question is on sets. So let us see how best we can answer this question on sets. Many are the times when the students really find it a challenge to answer such questions in the final exams, and when they are presented with that question, wow, they simply just go off and say, I cannot manage to interpret this information given the Venn diagram and see how best I can move on and then answer it confidently. Right, so the first question, the question reads for this session again, for our second session. It says the Venn diagram below shows tourist attractions visited by students in a certain week. The Venn diagram below shows tourist attraction visited by students in a certain week. So you are able to see the Venn diagram that has been presented there, but let me also write it here so that we are able to follow one another as I explain. So these tourists, they had visited places like Victoria Falls, Mambilima Falls, and Gonya Falls. So we have this as the universal set, and we have three sets. Let me say this is for Vic Falls, this is for Mambilima Falls, and this is for Gonya Falls. Right. So we have the information already tabulated to say here we have 6, here we have 2, here we have 10, here we have 4, and here we have 1 and 8 there, then 2y plus 1. That is the information that we have. Now, we have been asked to find the value of y if 17 students visited Mambilima Falls. What is the value of y if 17 students visited Mambilima Falls? So how are we going to look at this question? Mambilima Falls is this whole circle here represents Mambilima Falls. So if we add this, and that, we should be able to get 17, because that's what we have been told. Find the value of y if 7, not 17, if 7 students visited Mambilima Falls. Only. Yes. So, sorry, there is a question there. There is a condition that states only. That's a very, very, very important point that you need to put into consideration. Mambilima Falls only, 7 tourists visited. So let's look at these parts. If they say Victoria Falls only, then we are talking about this region here. So those that visited Victoria Falls only were 6. If they say Mambilima Falls only, then it will be these tourists. This is the region which is being talked about. And this region is represented by 2y plus 1. And they are saying, find the value of y if 7 students visited Mambilima Falls. So this 2y plus 1 represents the number of students that visited Mambilima Falls only, meaning these students or these tourists did not visit either Victoria Falls nor Gonya Falls. They only went to Mambilima Falls. They are not part and parcel of the intersection set of Victoria Falls and Gonya Falls. So we are going to say 2y plus 1 is giving us 7. This is just a simple linear equation which we can sort out, and we're saying 2y, if we transpose this 1 to the other side, we have 7 minus 1. And then 2y equals 7 minus 1 is 6, then dividing throughout by 2, then we have our y to be 3. So find the value of y if 7 students visited Mambilima Falls only. So the value of y is 3. We can also confirm if the value of y we have found is correct by replacing it where there is y into that equation. So the equation is 2y plus 1 equals 7, and we have found the value of y to be 3, and we want to see if what is this side is what is this side. So 2 and 3 there plus 1 equals 7. If we multiply 2 by 3, that's 6 plus 1, then we're going to find the 7 that is on the right hand side. So that gives you confidence that the value of y that you have found is correct. Thank you so much also to those that are still tuning into MTN Teleschool. Longo there, we are grateful. Ngosa Junior Chulu and many others are also tuned to this MTN Teleschool revision exercise that we are doing today. We move on now to the next question. How many students visited 2 tourist attractions only? How many students visited 2 tourist attractions only? let's get back to our diagram that I earlier drew. Two tourists that we're supposed to find how many students visited two tourist attractions only. So the only part of two tourist attraction here is when you look at the intersection of V and M, the Victoria Falls and Mambirima Falls, you find that this region is that which represents two tourist attractions only. The intersection set of M and G, just this portion here, is what represents the two tourist attractions, only this and this, and also this one here. So to answer this question, we are going to say the number of tourists that, how many students visited two tourist attractions only, we are going to have the first one 2 plus this 1, then plus this 4. And this gives us 2 plus 1 plus 4, and we have our answer as the 7. Right, so that is what you expected. Now they're saying, how many students, the next question, how many students visited one tourist attraction only? One tourist attraction only. Here now, we are looking at this region. For Victoria Falls, we are interested only on this region. I hope you're able to see this region. For Mambirima Falls, the only part is this region. I hope you're able to follow as well. Then for Gonya Falls, the only part is this. So we are being asked to calculate or to find how many students visited one tourist attraction only. So we have the 6, and here remember we already found it was 7 and 8. So we are saying part C of this question is going to be 6 plus the 7 we had already found plus the 8 here. So 6 plus 7, this gives us 13, and 13 plus 8 gives us 21. So 21 students visited one tourist attraction only. So there you go. That's how you are expected to answer these questions on sets. Please, you do not need to struggle. You need to spend much time to think and look at the question that has been given. What are you being asked? What is expected of you to do that question? And you move in that direction as expected. So we also want to thank many of our people that are following us. I can still see Ngosa Junior there, Chulu appreciating what is happening. Pule also is saying hello, is enjoying all these things, the presentation that is taking place here. Please don't forget to tag your friends and family so that they can join us in the revision exercise. Those that are asking that, why can't we do it in the evening? This live streaming will be uploaded on the MTN TV Plus, and you are able to view it at your own time, even in the evening. Right, so we move on to another question. Question 4. Question 4 is based on single fraction. I think this question, even at grade 9, it's also tested and examined, and it gives 3 marks in the final exam. They are saying express as a single fraction in its simplest form, and you have yourself 3 marks. So we have 3 over everything over 5x minus 2, then minus 2 everything over x plus 3. These are algebraic fractions, and we've already ascertained that algebra is simply a branch of mathematics that deals with the use of letters, symbols, and signs in place of numerical values. And when you look at the fractions that have been given, they are simply algebraic fractions because we already have letters like x which are appearing there. But where do we draw the concept? How then can we answer this given algebraic fraction? Remember when we are dealing with numeric fractions at grade 3 or 4, 5, if you have 1 over 2 plus 1 over 3, the concept is that you find the common denominator between 2 and 3, which is 6, and then you say 2 into 6, this gives us 3, then this 3 multiplies the numerator there, so you have 3 plus 3 into 6, which is 2, and 2 when you multiply it with 1, you still have 2, and then 3 plus 2 gives us 5 over 6. The same concept that we use when dealing with numerical fraction is the same concept that we use when we are solving or we are expressing algebraic fractions in simplest form. So you can see that earlier on I had 2 fractions which I have merged by this operation, and I'm able to get 5 over 6. Now let's get back to our question. Our question here reads, we need to express 3 over 5x minus 2 minus 2 everything over x plus 3. We are going to use the same concept that we use on numerical fractions. And here we are going to look for the common denominator, where 5x minus 2 and x plus 3 will go into. And in this case, we are not going further than anywhere. We are just going to pick these same 2 factors here. This is what is going to be our denominator. So we have 5x minus 2 and x plus 2. Okay? Then we are going now to work them out. 5x minus 2, when it goes into this denominator, so this 5x minus 2 and 5x minus 2 will cancel, will remain with x plus 2. Then this x plus 2, we are going to multiply it with the 3, the numerator which is there. So we are going to say, to write it properly, we'll say 3, then we get x plus 2, then minus. Then we can also say x plus 3 into this common denominator, 5x minus 2 and x plus 2. Sorry, here we've made a mistake. It's x plus 3, not x plus 2. I hope you're able to follow. Then x plus 3 and x plus 3, if this goes into here, we are going to have 1. And that 1 should be multiplied by 2 there. Then we have just 2 there. No, we have 2, and then the other factor, which is 5x minus 2. I hope you're able to follow. Most of us as students, we end up making big mistakes by just getting this and place it there, getting this and place it there, which is a very, very big mistake that is going to cost you lose marks in an exam. Now, having done that, we are going to expand the brackets now. 3 times x, we are going to have 3x plus 3 times 2, we are going to have 6, then minus 2 times 5x, we are going to have 10x. But please remember that this negative sign is being distributed even to that which is inside. So don't make a mistake of just simply getting this sign and put it here. So we're saying negative times negative, this gives us positive. So 2 times 2 gives us 4. Everything should be under the common denominator that we've already found, which is 5x minus 2 and x plus 3. Right. So this common denominator now has just to carry on. You don't need to struggle and do all that. You just have to carry it on up to the very end of the simplification. Now that you have expanded the brackets as numerators, you need now to collect the like terms. So this 3x and this negative 10x will be combined together, will be collected together. So we're going to have 3x, we lift it together with its sign, minus 10x. Please, we are not transposing it, so the sign will not change to positive from there. Then plus 6, then plus this 4. Then everything should be over 5x minus 2 and x plus 3. We close the bracket here. Then when you simplify 3x minus 10x, we are going to have negative 7x plus 6 plus 4, we are going to have 10. Everything over 5x minus 2 and x plus 3 as a common denominator. This is your answer, but there is no harm in rewriting this expression to say you start with that which is positive. You can even say 10 minus 7x everything over 5x minus 2 and then x plus 3. You have not changed anything from this point. This is just one and the same thing. So I hope you are able to follow us. Thank you so much to Nirenda Zilole Matthews, who is also following us. Mwanza Kabindula Daisy has also tuned in. Benjamin Kabondo Makungo is also watching with us and is also happy that the discussion is moving on very well. Right, now we look at the other question here, and this question is based on some basic calculus that you need to know. I'll spend some time and I'll be a bit slow to explain this concept so that we get it. Okay, earlier on we had looked at calculus having two branches, that of integration and that of differentiation, and we looked at a certain question where we said in terms of differentiation, when we've been asked to differentiate with respect to a certain value that is a variable that is in the given question, the power loses. For example, if we have y equals this an expression or a function that we need to differentiate, 3x the power 3 plus 2x to the power 2. We said if they say, can you differentiate with respect to x, or they ask you to find the derivative of this function, we say this can be dy over dx. The power will multiply this base, but as it multiplies this base, it loses by 1. Also, this power multiplies this base, it loses by 1. You may not necessarily master the formula, you just need to know what to do. Because when you know what to do, even if you forget the formula, you'll be able to work out the question as it comes out. So the dy dx of this will say 3 times 3, this gives us 9x, and when this 3 loses the power, we're going to have 2, then plus 2 times 2, we have 4x, and then 2 minus 1, we just have 4x. So we have differentiated with respect to what? To x. And so we can also ascertain to say this is differentiation, but integration is the reverse of differentiation. So when you are differentiating, we are losing the power, but in integration, we are gaining, the power is gaining by 1. So then how do we go about integrating? We've been asked to evaluate this given expression. This is a symbol of an integration, 5 and 2 here. Then we have 3x squared plus 2, right? Then with respect to x, we are supposed to evaluate that one. Like I said earlier on, if we are integrating this, this is going to be, this value will go up by 1, and then we are also going to divide the new power with the expression there. So we are going to have 3 over 3, then x to the power 3, because the new power is that, then plus 2. When we integrate this with respect to x, we are going to have that. Right. So then we have x to the power 3 plus what? 2x as the integrated expression. Now from here, we need to bear in mind that we have, we're supposed to have it's raised to 5 and 2 there. So we are going to have these expressions where we say x to the power 3 plus 2x minus, this is 5 now, and then x to the power 3 plus 2x, and we have a 2 there, right? So we're going to replace 5 wherever there is x. So we're going to say 5 cubed plus 2, and then 3 here, minus, you can say this, minus 2 cubed plus 2, and then also their x, we do like that. Then we say 5 cubed is going to give us 125 plus 6, then minus 2 cubed is going to give us 8 plus 4. Then we are going to say 125 plus 6. This is going to give us 1, then 3 and 1, 131, then minus 8 plus 4, that is going to give us 12. So when we subtract this, we are going to have 131 minus 12. I'm sure you're able to find that our answer is good. 131 minus 12, which simply give us 119. So that is basically what you need to look at when you're looking at integration. So thank you so much for joining us. This has been an afternoon session on paper 2 2017 GCE. We are grateful to all those that are following us. Please join us in a few minutes at 16 to 17 when we shall continue looking at the next question in this paper. Hope you've enjoyed the session. Thank you so much once more. My name is Anton Samanenga. See you later.
Tiende pamoja ni mtima umo. 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 Tiende pamoja